Hi everyone, this is Mrs. L, and this lesson is 12.1b, Trigonometric Functions in Right Triangles. Alright, so the first thing is we are going to be using our calculators, so make sure you guys have those on hand. And also make sure that you put your calcs in degree mode as opposed to radian mode. Alright. So the first thing we're going to do is we're going to solve for this right triangle. We're going to solve for x using the trigonometric function to find the value of x and round to the nearest tenth. All right. So the first thing we're going to look at is what we have. So we have the angle right here of 38. And then we have that the opposite side is 10. And we're looking for the adjacent side. So you want to use one of the 6 trigonometric functions you learned yesterday or on the last lesson. And we noticed that since we're using the opposite and the adjacent, we should be using tangent to represent that ratio. All right, so that means tangent of 38 degrees is equal to 10 over x. All right, and then we solve for x, so I'm going to multiply the x and then divide the tangent 38 degrees. So we get x is equal to 10 over tangent of 38 degrees. All right, go ahead and type that into your calculator, and hopefully you're getting 12.8 when you round that to the nearest tenth. If you're not getting that, again, just double check and make sure that you are in degree mode. Okay, let's try it again. For number 2, we have 63 degrees up there. And from that angle's perspective, 4 would be the adjacent side, and x would be the hypotenuse. So that would be the trig function cosine. So that means cosine of 63 degrees is equal to 4 over x. All right, I'm going to multiply x on both sides and divide by cosine of 36 degrees. So I get x is equal to 4 over cosine of 63 degrees. And that gets me 8.8. All right, why don't you try number 3 on your own? So pause the video real quick, try it on your own, and then once you're ready, check your answer with mine. All right, so the answer for number 3, once you're ready, should be x is equal to 5.0. And there's my work right there if you need to see how I got that. Okay, so that's just kind of getting you guys used to using your calculators to solve for a side in a right triangle. All right, now we're going to talk about what if we don't know the angle, but we know the sides. So if we don't know the angle, what we need is the inverse trig functions, all right, the inverse trig ratios. So we have inverse sine, inverse cosine, and inverse tangent. And these guys are used to find the angle, all right, that gives a certain ratio, all right. So first thing, I don't want you guys to confuse this with a reciprocal function. All right, so that's a very important distinction. So this note on the side here is talking about how inverse functions are not the same as reciprocal functions. I'll even write that down. So inverse does not equal to reciprocal. And I know that gets confused a lot because a lot of the times, or we see with exponents, we see that, you know, if we have 2 to the negative 1, that equals to 1/2. And we automatically think like, okay, if I see that negative 1 up there, that means reciprocal. With exponents, it's true, but when we're talking about functions, it actually, the negative 1 does not mean reciprocal, it means inverse. So let me give you an example. So let's say I have the function f of x is equal to x cubed. All right, so the inverse function of x cubed is the cube root. But the reciprocal function is 1 over x cubed. And you can see that these are definitely not the same. All right, they're not equal. So just notation-wise, make sure you distinguish between the two, all right, between inverse versus a reciprocal. And in this case, we're talking about the inverse of these three trig functions. All right, so inverse sine, inverse cosine, and inverse tangent. And that allows us to find missing angles. All right, so let me show you guys how that works with number 4. It says find x and round to the nearest tenth if necessary. All right, so we're actually going to do basically what we did before. We're going to look at the angle and look at the sides from the angle's perspective. So 4 would be the adjacent side and 7 would be the hypotenuse side. All right, so looking at those two, we're going to be using cosine of that angle x is equal to 4 over 7. All right, so notice things are a little bit different. Our unknown is not part of the ratio. Instead, our unknown is our angle. So that's how we know to use inverse cosine, is when you don't know the angle. All right, so what that means is our angle x is going to be the inverse cosine of that ratio 4 over 7. All right, so go ahead and find that on your calculator. Typically it's going to be like the shift button or the second button and then cosine, and that will give you your inverse cosine. And if all goes well, hopefully you are getting an angle of 55.2 degrees. Okay, let's try it again. So number 5. All right, so this time we have our angle x up here. And once again, we have an adjacent and hypotenuse with respect to that angle. Using cosine x to some degree is equal to 13 over 33. All right, so again, because our x, our unknown, is our angle, we're going to have to use inverse cosine. So you can almost think of it as inversing cosines both sides, right? To kind of get rid, quote unquote, of the cosine. So we're going to inverse cosine both sides, and then that leaves just x on one side and inverse cosine of 13 over 33 on the right hand side. All right, type that into your calculator and we get 66.8 degrees. Quick note, I would make sure to write degrees just because there's another type of angle measurements we're going to talk about later on called radians. And so to distinguish between degrees and radians, we always make sure to write the degree mark when we mean degree. Okay, why don't you guys go ahead and try number 6, pause the video, and once you're ready, go ahead and unpause and you can check your answer. Okay, so the answer for number 6 was x is equal to 23.6 degrees. Okay, let's go ahead and flip to the next page. So now we're going to go into some word problems involving these trig functions. Now, the first thing I want to teach you is just kind of terminology called angle of depression and angle of elevation. All right, so angle of depression, for both of these angles actually, you always start with a horizontal line. All right, they always start with a horizontal line. And the angle of depression just means you go down from that horizontal line. So in this case, we have this angle going down from the horizontal, and this is the angle of depression. And then, if you're talking about an angle of elevation, Once again, you always start at a horizontal line. That is key. All right, so start at the horizontal. Angle of elevation is how many degrees you go up from that horizontal line. All right, so let's go ahead and try out some more problems. So number 7 says, what is the angle of elevation of the sun when a tree 6.25 meters tall casts a shadow 10.1 meters long? All right, so I'm kind of a visual learner, so I'm going to go ahead and I'm going to draw a tree. Okay, and then we have the sun, which I'll just put here. Okay, and just go ahead and think about how a sun casts a shadow. So light from the sun hits the tree, and it creates a shadow on the floor right here. So that is the shadow. All right, so that is our right triangle right there. So the tree is 6.25 meters tall, and the shadow is 10.1 degrees. Oops, excuse me, meters. Okay, and it says, what is the angle of elevation of the sun? So the question is, well, what angle are we looking for? So if you remember, angle of elevation is always from a horizontal line. So there's our horizontal, and we want to go up to find that angle of elevation. So this angle right here is our x. That's what we're trying to find. Okay, so from that angle's perspective, we have an opposite, we have an adjacent, so we are going to set up a tangent function for x to be 6.25 over 10.1. And since it's the angle that we don't know, we're going to be using inverse tangent. So x is going to be equal to inverse tangent of that ratio. All right, plug it into your calculator, and we get an angle of 31.7 degrees. Okay, let's try another one. So number 8, how far from the base of a building is the bottom of a 30-foot ladder that makes an angle of 75 degrees with the ground? All right, so let's go ahead and we'll draw this building. Okay, and there's the ground, and there is a ladder. All right, so let's say this is our ladder, okay, of the building, and it says it's a 30-foot ladder, so that ladder is 30 feet, and it makes a 75-degree angle with the ground. All right, and now the question is, how far from the base of a building is the bottom of that ladder? So we're looking for this distance right there. All right, so that I will label x. Okay, so let's set up our trig function here. So we have an adjacent and a hypotenuse. So this is going to be cosine of 75 degrees is equal to the adjacent, which is x, over the hypotenuse of 30. So multiplying 30 on both sides, x should give me 7.76 feet. And that is my final answer. All right, why don't you go ahead and try one on your own? So number 9, go ahead and pause this video, and then once you're ready, unpause and check your answer. All right, if you're done with number 9, go ahead and check your answer with mine. And my final answer was 225.2 feet. Okay, so there's my picture. I have my roller coaster. Angle of depression is 60. So remember, always start from the horizontal. And then we're going to go downward 60 degrees. And the vertical drop is 195. So we want to find the length of the hill, which is this hypotenuse right here. So that sets up sine of 60 degrees is equal to 195 over x. Multiply x on both sides, multiply or divide sine of 60 degrees on both sides. That gets me 225.2 feet. And that's it.